Class, in this video, we learned about the inverse sine function. The basic sine function, y equals sine of x. We learned how to graph the sine function, the cosine function, and the tangent function back in section 5.3. So the basic sine function, y equals sine of x, is not a one-to-one function. It fails the horizontal line test. So down here, right, is the graph of the sine function. We did that back in section 5.3. And you can see that this indeed is the graph of a function because it passes the vertical line test. No matter where you draw the vertical line, right, it intersects the graph in only one place. But it fails the horizontal line test. No matter where I draw the horizontal line, it intersects the graph in more than one place. So it's not a one-to-one function. So as it's drawn, right, it does not have a inverse function. The domain of the sine function, right, you know, is all real numbers, and the range is all real numbers from -1 to 1, right? So remember, the range is the y values. They go from -1 to 1. And you can take the sine of any angle, so the domain is all real numbers. Well, mathematicians way back when wanted an inverse sine function. So how do they get around this problem? What they decided to do was just use part of the graph of the sine function. Just use a part of the graph from -pi/2 to +pi/2, which we have drawn down here, right? The graph part here in blue, from x equals -pi/2 to +pi/2. And then so everything to the left of -pi/2 is thrown away, and everything to the right of +pi/2 is thrown away. And we're just left with this blue piece right here. And its range, this blue piece, is still -1 to +1. Okay? And you can see this section of the graph of the sine function up above, this section right here, passes the horizontal line test. No matter where I draw the horizontal line, it intersects the graph in only one place. So by restricting the domain, this is called restricting the domain. By restricting it, they can now create an inverse sine function. And so down below we have the graph of the inverse sine function. And the mathematical notation for the inverse sine function is to put a -1 in the superscript on the sign. This does not mean reciprocal. This means the inverse sine of x. And so in the graph of the inverse sine function, the numbers on the y-axis from -1 to 1 are now on the horizontal axis of the inverse sine function, right, from -1 to 1. And the angles from -pi/2 to +pi/2 are now, right, on the x-axis up here, are now on the y-axis down here. So remember, for an inverse function, right, the input and the output gets switched. So here's the graph of the inverse sine function. And again, the domain is from -1 to +1. Right, those are the numbers we can put in for x up here, and the range is the angles in radians from -pi/2 to +pi/2, which is the same as -90 degrees to +90 degrees. So this point right here, right, has an x coordinate of 1/2 or 0.5, and the output angle is pi/6. So the inverse sine of 0.5 is equal to the angle pi/6 radians. So on the next page, I have the domain and the range of the inverse sine function summarized. Again, this is the equation, y equals the inverse sine of x, right? X is a number and y is an angle. So for each number we put in for x, we get some angle between -90 degrees and +90 degrees. So the domain is -1 to 1. Those are the numbers we can put in for x. and then the output angles are between minus 90 and plus 90 degrees, or between minus pi over 2 radians and plus pi over 2 radians. So if y, an output angle, is equal to the inverse sine of the input number x, then it has to be true that the sine of that angle y is equal to the number x. And so the range is minus 90 to 90 degrees. So back in when we talked about the unit circle, on slide 14, we talked about negative angles using a unit circle to find the sine and cosine and tangent values for negative angles. So here's minus 90 degrees, right? To draw the angle minus 90 degrees, you start with the positive x-axis and you draw it in a clockwise direction. Remember, angles drawn in a clockwise direction are negative. So minus 90 degrees and 270 degrees, right, are in the same have the same terminal side on the unit circle. And so minus 90 degrees is down here, and then we go counterclockwise to 0 degrees, and then from 0 degrees continue counterclockwise to plus 90 degrees. So the output angles for the inverse sine function go from minus 90 degrees down here up to 0 degrees and then up to plus 90 degrees. So let's summarize the relationship between the sine function and the inverse sine function for these angles. So over here in the table on the left, I have the angles on the unit circle listed from minus 90 degrees to plus 90 degrees. And then their corresponding radian measured. And we know from the unit circle, right, the sine of minus 90 degrees is the same as the sine of minus pi over 2 radians, which is equal to -1. So that means the inverse sine of the number -1 is equal to the angle minus pi over 2 radians, or minus 90 degrees. Okay, so with the sine function, right, you input an angle and output a number. With the inverse sine function, you input a number and output an angle. Okay, so let's do another one down here at 30, right? So here we have 30 degrees and pi over 6 radians, right, are the same angle. And so the sine of 30 degrees, or the sine of pi over 6 radians, we know is equal to 1/2. And so the inverse sine of 1/2 is then equal to the angle pi over 6 radians, or 30 degrees. Okay, so that's how it works. So let's take a look at some examples on page 4 of your note packet. We're going to find the exact value of each expression. So yeah, so what's the inverse sine of 1? So we know that's the inverse sine of 1 is going to equal an angle. What angle is it going to equal? Well, from the table on the previous page, we know that the sine of 90 degrees is equal to 1, and the sine of pi over 2 radians is also equal to 1. So therefore, the inverse sine of 1 is equal to the angle 90 degrees, which is the same as the angle pi over 2 radians. What's the inverse sine of the number 0? Well, we know from the table on the previous page that the sine of 0 degrees is equal to 0, and the sine of 0 radians is equal to 0. Therefore, the inverse sine of 0 is equal to the angle 0 degrees, or 0 radians. 0 degrees is the same as 0 radians. And lastly, what's the inverse sine of the number minus square root of 2 over 2? Well, from the table on the previous page, right, we know the sine of minus 45 degrees is equal to minus square root of 2 over 2, and minus 45 degrees and minus pi over 4 radians are the same angle. The sine of minus pi over 4 radians is also equal to minus square root of 2 over 2. So consequently, the inverse sine of minus square root of 2 over 2 is equal to the angle minus 45 degrees, which is the same as minus pi over 4 radians.